Hello everyone. We have a question which says that three coplanar forces of magnitude 20 Newton, 100 Newton and F Newton act at a point. What are coplanar forces? Coplanar forces are the forces which act at a single point. And if we look at the diagram, this 20 Newton force, F Newton force and 100 Newton force all are acting at this particular point. That means all these three forces are coplanar forces. The condition that they have given us is that the directions of these forces are given. Yes, we can see the direction alpha 40 degree and 20 degree, and the condition that they have given us is that the forces are in equilibrium. That means when the forces are in equilibrium, the opposite forces are equal. And when I say the opposite forces are equal, that means the opposite horizontal forces are equal and the opposite vertical forces are equal, and for that we have to split up the condition into horizontal component and vertical component. Before that, we should understand what the horizontal and vertical components are, because I have seen most of the students have a misconception and they think that the horizontal component is always a cos component. No, it is not like that. If this is the angle that is given in the diagram, then the side next to that would be a cos component side of that particular force, and the opposite side would be a sine component of that particular force. But if the angle is over here, then the side next to it would be a cos component of that particular force and the opposite would be a sine component of that particular force. That means it is not like that the horizontal component is always a cos component. It depends upon where the angle is. As we can see in the diagram, I have split it up the horizontal component as well as the vertical component. So if we just look at F Newton and angle alpha, which is with the x-axis, so the horizontal component of that would be F cos alpha and the vertical would be F sin alpha. Similarly, 20 Newton force making an angle of 40 degree with the x-axis, so the horizontal component would be 20 cos 40 degree and the vertical would be 20 sin 40 degree pointing upward. And if you look at the 100 Newton force, which is making an angle of 20 degree not with the x-axis but with the y-axis, that means now this vertical component would be a cos component because we have the 20 degree with the y-axis. So the vertical component this time would be cos component pointing downward, 100 cos 20, and this would be 100 sin 20. That means the component from here till here. The condition is an equilibrium. We have splitted up the components as I have mentioned in the diagram. Now let us continue with the condition of equilibrium. As we can see, we have two things, that is the horizontal and the vertical. So first of all, let us talk about horizontal. In horizontal, we have two forces over here, the 20 cos 40 and 100 sin 20 to the left and F cos alpha to the right. So adding this 20 cos 40 plus 100 sin 20, 20 cos 40 plus 100 sin 20 would be equal to F cos alpha over here, and by simplifying the 20 cos 40 degree plus 100 sin 20 degree, which is 49.5, we can say that F cos alpha is equals to this, equation 1. We would create another equation based on the vertical forces, and if we just look at the diagram, we have two forces pointing upward, the vertical forces, the 20 sin 40 and F sin alpha. Just add them up, F sin alpha plus 20 sin 40, and just one force pointing downward, which is 100 cos 20 over here. Just move this 20 sin 40 on the other side, subtract it, simplify it, we have 81.1, and we can say that we have another equation, F sin alpha is equals to 81.1. Now because we have two equations and we have to find the value of F and alpha, we have two different methods to solve it. Both methods are super easy. It is up to you whatever method you want to apply. We will discuss both the method. So the first method is dividing equation 2 by 1. That means dividing this F sin alpha divided by F cos alpha would be equal to this 81.1 divided by 49.5, and after cancelling this F, sin upon cos would be tan, and 81.1 divided by 49.5 would be 1.6384, and taking the tan inverse of 1.6384 would give us the angle alpha, which is 58.6. Definitely that we have to find. Now, because we have found the value of this alpha, just place this alpha in when any of the equation, whether the equation 1 or whether the equation 2, place it over there and get the value of f. So if we take equation 1, which is f cos alpha is equals to 49.5, place the value of this angle 58.6 over here, divided below 49.5, and you will get the value of f as 95 Newton. Very easy method, as super simple. And if we talk about the method 2, which is also very simple, that is squaring and adding equation 1 and 2. Equation 1 is f cos alpha, equation 2 is f sin alpha, and if we add them, but before that we have to square, because the condition is squaring and adding. So first of all square them and then add them, and definitely f cos alpha was 49.5 over here and f sin alpha was 81.1 over here. So just square them, add them, and get the answer as 9027.46. Open up the bracket, simplify them. F square cos square alpha plus f square sin square alpha. Take f square as common. We are left with cos square alpha plus sin square alpha, which is an identity, equal to 1. So we are left with f square is equals to 9027. Taking the square root on both sides, and finally we can say that f is equals to 95 Newton. Definitely the same answer which we got from method 1. Now placing this value of f in any of the equation, for example, if we take the first equation, which is f cos alpha is equals to 49.5, placing this value of f as 95 Newton over here, dividing, we have 0.5 to 1, and then taking the cos inverse of it, the same answer of alpha 58.6 that we got from the first method. Both the methods are super simple. It is totally up to you which method you have to apply in your exams.